My name is Jan Harzan. I'm the Executive Director for MUFON. We are a scientific research organization that basically collects sighting reports from the public and then goes and investigates them. Our mission statement as an organization is the scientific study of UFOs for the benefit of humanity, and we have three primary goals. We investigate UFO reports, we promote research into the UFO subject, and we educate the public on our findings. MUFON is really more just left of center, where we try to take a scientific approach by collecting the data first off, and then reviewing the data, investigating the data, and making sure that what we're seeing is actually something that's truly an unknown. We have 3,000 members worldwide. Many scientists, physicists, PhDs, metallurgists, biologists, all the way down to just the average citizen who really wants to get involved. Some of those have chosen to become field investigators, and they go through our field investigative training courses. They become part of the team in their state or country where they reside, and they actually get engaged in going out and meeting this phenomena head on. We receive about 500 to 1,000 reports per month from around the world. Field investigators will take the case, generally review it, try to come up with a hypothesis, checking star charts, and we'll go put an investigation in place to determine what exactly happened. We've recently formed a science review board, and that board is made up of scientists from around the United States and around the world to review some of our more significant cases and try to render an opinion on them. What we'd like to do is be more outbound, more outspoken in terms of the really true UFO cases. So MUFON is moving forward with this approach, and we'll be publishing papers in these different areas to allow the general public and even the scientific community to be able to be challenged by what we're finding. That's the strength of MUFON as an organization, is being really the truth seekers of the UFO field.
Good morning. Our next speaker, Robert Schroeder, has lectured around the country, helping to educate the public about the evolution of modern physics, recent theories, and potential explanations for UFO technology. Schroeder served in the U.S. Army between 1966 and 1968, which included a tour in Vietnam. He earned a BA degree in math from Rutgers University, an AS in aerospace engineering, and an MBA. He recently retired from Hewlett-Packard after 26 years in operations and product management. Here to speak about how modern physics is revealing the technology of UFOs, Robert Schroeder.
Okay, thank you, John, for that great introduction. And I'm the author of this book, Solving the UFO Enigma, and the title of today's talk is also the subtitle of my book, How Modern Physics is Revealing the Technology of UFOs. And in a nutshell, the basic thesis of the book is I believe that a subset of all UFO reports are real craft from other civilizations. And the second major thesis of the book is that I think modern physics is pointing toward a very likely explanation of UFO technology. And that's what we'll get to see here today, what's going on in modern physics and why I believe that we here on Earth may very well be on the threshold of understanding UFO technology. The most important thing is the UFO evidence that we have now accumulated over many, many decades. And it's a tremendous amount of data. And the interesting thing is that these reports go back at least to the 1930s, right into the 21st century. But what we really have to pay attention to are the interesting characteristics of UFOs. And in fact, these odd characteristics of UFOs are what make UFOs UFOs. And of course, everybody here who's followed the UFO phenomenon for many, many years is well aware that one of the interesting characteristics of UFOs is their unbelievable accelerations, as you may have seen in the DVD we just showed. These things are capable of phenomenal accelerations. And the reason we need to pay attention to these UFO characteristics is because I believe they are revealing aspects of their technology. So it's important that we pay attention to the unusual behavior of these craft. And then, of course, another very common characteristic is their ability to levitate. And so how the heck are they doing this, especially when you consider the very bottom item on the slide here? Ted Phillips of MUFON did a study of UFOs which had landed, and he estimated that their typical weight was between the smaller 40, 50, 100-foot craft. He estimated that their characteristic weight was around 50 to 100 tons, or 10 to 30 tons. And so if you can imagine an object of that much mass accelerating at these unbelievable speeds, that's what makes these UFOs so unusual. Now, another thing is their ability to become partially and then completely transparent. And at the Captain Charles Duboc, as we saw in the DVD there, was an eyewitness along with his crew of a gigantic 800-foot metallic red UFO over France that he saw become partially transparent and then totally disappear. And there are numerous other reports of this behavior, and it's and again, I think this is critical to understanding what UFOs are doing. And then another odd thing about UFOs is the puzzling, strong, attractive gravity field that appears to be just short range near the UFO. And for example, many times people have reported that as UFOs come close to a body of water, they will actually lift up a large mass of water toward the bottom surface of their craft. And this has been reported many times. And so it's really kind of strange, but you know, you would think if they're using anti-gravity that they would be pushing the water down, but we're seeing, at least when they come close to the water or objects on land, they're lifting things up. And then one other characteristic is consistent shapes. They are typically spheres or cylinders or discs or a delta-shaped craft. And so we'll try to, in the slideshow today, I'll show you why I believe they have all these characteristics. And you'll see how they all tie together. But I'm just going to do a couple of other UFO encounters that are extraordinarily good UFO eyewitness accounts. And one of them occurred back in 1981 over Lake Michigan. A Captain Phil Schultz and his first officer observed a round UFO with 6 jet black portholes on a perfectly clear summer day. And the UFO approached from maybe 40,000 feet, and they were flying at around 30,000 feet. It flew directly in front of their L-1011 commercial airliner, and it ended up doing a 20G turn right in front of their craft. And to give you an idea how close it was to their aircraft, they actually braced themselves for a collision. They thought they were going to collide with this thing. But the maneuverability of the UFO, its ability to overcome inertial forces, showed, in this case, they were, fortunate, and the thing got out of the way in a hurry. But here's the cockpit view of what they saw. And on the upper right here, you can see where the UFO came in, made an incredibly sharp turn. And keep in mind, a 20 G turn, 20 times the force of gravity, the best that humans can do in a fighter jet with the proper G-suit equipment is about 10 Gs, and that's at the very limit of human capability. And this thing did 20 Gs, literally right in front of their aircraft, and they were just astounded. That's again, that's an excellent example of how these UFOs overcome inertial forces. Inertia is the resistance to acceleration. But Captain Schultz's reaction to the UFO encounter was very interesting. Even though he had extensive experience as a fighter pilot, a US Navy fighter pilot, totally rejected UFO reality. Despite that, he told Dr. Richard Haynes, a NASA scientist who's investigating UFOs, he told him that there is no doubt in his mind that it was an extraterrestrial craft. So you can imagine, that's kind of amazing. And as we saw in the video there, Captain Charles Duboc saw the UFO fade and totally disappear. If we're going to understand the UFO phenomenon, we have to be able to explain that characteristic of UFOs. And then a much more recent sighting of UFOs disappearing was just last year, December of 2014. A Canadian pilot saw a cylindrical shaped UFO become partially transparent and then totally disappear. And so the two big questions on UFO technology are, number one, how do they get here? And number two, how are these craft able to perform inertia-defying acrobatics in Earth's atmosphere? And so we're going to look at the first question, how did they get here? And modern science, current theories, and currently accepted physics has proposed 3 different methods how they might get here. If somehow they could go faster than light, or near light speed, or perhaps they're warping space-time. And but the problem with all 3 methods is that a gigantic amount of energy is required. People here may have heard of the Alcubierre warp drive, but unfortunately that requires a huge amount of energy, and so that the problem with that is that, like Professor Michio Kaku, the Columbia physicist, has pointed out that the amount of energy needed to get across the galaxy, you would have to convert about half the stars in our galaxy, the Milky Way galaxy, from matter to energy in order to get the energy to warp space to get across the galaxy. And of course, if any of those other stars have inhabited planets, they may not take too kindly to, to us converting them to energy. And so at this point, I've got to tell you, I've got some good news and bad news. And the bad news is we're going to, in order to try to solve the UFO enigma, we're going to have to do some physics. And so so if you think it's bad so far, it gets worse. But the good news is there will be no quizzes or exams. So anyway, the 2 pillars of modern physics are general relativity and quantum mechanics. And I'm sure everybody's heard of these theories, and they're accepted theories from everything we understand. General relativity deals with the world of the very large. It deals with galaxies, planets, stars, the universe as a whole. And it explains the force of gravity, one of the 4 fundamental forces of nature. And quantum mechanics, in contrast, deals with the world of the very small, subatomic physics at the atomic level, electrons, protons, quarks, things like that. And quantum mechanics explains the other 3 fundamental forces of nature, which are electromagnetism, the strong nuclear force, and the weak nuclear force. And the strong nuclear force is what holds the nucleus together, the protons and neutrons and quarks in the nucleus. And the weak nuclear force is responsible for radioactive decay. Don't worry, you don't have to memorize this. And quantum mechanics also explains the electromagnetism. So it just so happens that 2015 is the 100th anniversary of Einstein's theory of general relativity. And it was originally published in 1915. And so I couldn't resist the temptation to put this in the slideshow. But also for another very important reason, because I believe gravity is one of the absolute keys to understanding the UFO phenomenon. And, okay. This is actually Einstein's field equations for general relativity. And the reason it's plural, that it has an S on the end there, is because this baby blows out into dozens and dozens of other equations. But it's actually very complicated to solve. And as a result, there have been, when it was first published, and when Einstein first published it, there were no, believe it or not, there were no exact solutions to the field equations. All the solutions were actually approximations. But despite its complexity, the concept behind it is actually quite simple. On the left-hand side of the equation, left-hand side of the equal sign there, that part of the equation explains the curvature or the shape of space-time. And the right-hand side explains the matter and energy that's responsible for curving space-time. And so that's basically it. So matter and energy cause space-time to curve. And that's the essentials of general relativity. Oh boy, here's where the fun begins. So, as I mentioned, the Einstein field equations are very difficult to solve. And the first equation on the top there is exactly identical to the one on the previous page, except I colored in the first term in red because what I'm going to do is expand that on the second line, and on the second line that expands into something called the Riemann-Ricci tensor. Don't memorize this. Anyway, that thing, that horrible looking thing, that blows out into that equation there, the second one there. And the upside down L is the Greek letter gamma. I'll tell you one thing, when you're studying physics, you got to learn the Greek letters. But anyway, and then I colored in blue one of the terms in there, in that second equation, partway through the equation, and I blow that out on the bottom, and that blows out to a further equation, and that's called the Christoffel connection coefficient. And anyway, that's the first term. If you go back up to the top equation, that's the first term. But each one of those terms with the subscripts, Greek letters mu and nu, and if anybody who knows the Greek alphabet, there's 4 of them in there, and each one of them blows out to something like this, okay? And that's just the beginning. And on top of that, you have to, here, if you look on the equation to the right there, that's the same original equation on that I showed 2 slides ago. I've just abbreviated the left-hand terms into the single term G, a subscript mu and nu. And, but unfortunately, all of those equations you saw on the first page there, and remember there's 4 sets of those, okay? You then have 10 more to solve. You got to multiply that by 10. So I hope you're getting an idea of how complicated the field equations are to solve. And then when you're all done with that, that's for only one lousy point in space-time. That's it. So I have to say, when they were first published, the field equations back in 1915, the physicists around the world were really excited. But then as they started digging into it, they began to realize how complicated they were to solve. And so what was the general reaction of physicists around the world? I summarized that on the next slide. And but you get an idea. What happened was so that's why the first solutions to the field equations were approximations rather than exact solutions. So you can imagine Einstein's amazement. And he was back in Berlin in 1916, just a few months after the field equations had been published. They were published in November of 1915. And he gets a letter from a soldier on the Eastern Front, on the German army on the Eastern Front, with the first exact solution to the field equations. And so it was Lieutenant Karl Schwarzschild who sent a letter to Einstein in early 1916 with the first exact solution to the field equations. And of course, Einstein, being back in Berlin, was kind of amazed. This is in the middle of World War I, and here's this guy serving as an artillery officer, and somehow he found the time to, read the equations and solve it. However, everybody will immediately recognize Lieutenant Schwarzschild's first exact solution to the field equations, the Schwarzschild black hole. And of course, everybody's heard of a black hole. And this was actually the first exact solution. And this is very, very interesting. The black hole is important, I believe, as we will see in the UFO phenomenon. And this is all about is that the equation on the right there, the R with the subscript S for Schwarzschild, is the radius at which a object is at the threshold of becoming a black hole. But any object with a radius less than the Schwarzschild radius, with the mass given there in that formula, M is for mass, becomes a black hole. But the only thing you really need to pay attention to on this slide is the bottom line there, where I mentioned that photons and other particles, even though they may be they're going at the speed of light, cannot escape a black hole. The speed of light is according to special relativity, is the fastest speed possible in the universe. And so that's very important. Don't worry about anything else you saw. Just remember that photons and any other particles, even if they're going at the speed of light, cannot escape a black hole. We're going to need that information later. And here's a really neat illustration of the magnetic fields around a black hole. And what's interesting here is how strong these magnetic fields are. They are enormously powerful. And again, keep that in the back of your mind because it figures into UFO technology, as we will see. Quantum mechanics is, as I mentioned at the beginning, is the other great pillar of modern physics. And basically at the turn of the last century, 1900, it was thought that energy was continuous like a wave. But Max Planck discovered that actually energy at this tiny, at subatomic scale, can only change in integer multiples of what is now known as the Planck constant. And so anyway, here's actually Planck's formula. This is one of the key formulas of quantum mechanics, and it shows how energy can only change by multiples of Planck's constant. And here's the Schroeder equation. And this describes subatomic particles' behavior in terms of waves. But if you look carefully at the formula, you'll see partway in, just beyond the equal sign, the letter h squared. That h, of course, is Planck's constant, so it figures in there. So, okay, where are we here? Let's see. So, and you'll be happy to know that from this point on, I'm only going to be there'll be no more formulas, that's it. and I'll just be dealing with concepts and just be showing illustrations and explaining the general background of physics that we need to know to help us understand how the UFO phenomenon can be solved. And so the neat thing about physics, which is why it's fun to study it, there's not that much to memorize, and believe it or not. And our universe is actually quite simple. It only consists of three basic constituents: matter particles, force particles, and space-time, which is the stage on which matter particles and force particles interact with one another to create everything we see around us. And so force particles, people are familiar. The photon that carries the electromagnetic force. And matter particles, of course, everybody's probably familiar with an electron in an atom. And electrons are negatively charged particles that exactly balance the positive proton in the nucleus, and the electrons circle around the nucleus of an atom. And here's a typical basic atom. It happens to be a hydrogen atom, and it shows the electron going around the nucleus. And in this case, I showed the nucleus having a proton and a neutron, and those are the two basic particles that can be in the nucleus of an atom. And the reason I'm showing this is to illustrate the electromagnetic force between the electron and the proton that holds the electron in orbit around the proton, unlike attracts and like repels and charges. And the simplest possible atom is a basic hydrogen atom that only has a proton in the center and an electron in orbit around it. But I showed the neutron here just to show you can have neutrons in the nucleus too. This is actually an isotope of hydrogen, which they call deuterium. And the proton itself breaks down into smaller particles called quarks. And so there's three of those in there. And the quarks are held together inside a proton by a particle called the gluon, which is the carrier of the strong nuclear force that I mentioned at the beginning. And so that's important just to see where it comes into the picture. And here's what I mean, that physics isn't, there's not much to memorize. As hard as it might be to believe, the number of matter particles is only matter particles and force particles out there, that's it. The number of matter particles is actually very limited. There happens to be three families, first, second, and third, of matter particles, and they're referred to as fermions, named after the Italian physicist Enrico Fermi, who did a lot of the work categorizing the different particles of subatomic particles. And And anyway, but 99.999% of all the particles in the universe that make us up and every star that you see out there are actually made up of only the first column there, the first family. And they're broken into two categories, quarks and leptons. And there's only 4 particles. That's it. The up quark, the down quark, the electron, and the electron neutrino. And that's it. And once you memorize that, you got it. And similar, the same kind of thing with force particles. They're called bosons, after an Indian physicist who did a lot of the work cataloging and categorizing the force particles of nature. There are actually, as I mentioned, there's only 4 fundamental particles. The strong nuclear force, the weak nuclear force, electromagnetism, and gravity. And the strong force is carried by gluons. The weak force by W plus, W minus, Z neutral. The electromagnetism by the photon. And very importantly, because we need to know this for the rest of the thing, gravity is carried by a particle called the graviton, which is the only one of the 4 particles force particles that has not yet been seen in particle accelerators, but we hope to see it soon. The Higgs field at the bottom is responsible for giving mass to the subatomic particles, but we don't have to worry too much about that. And now here is where it gets really interesting, and this is where we're starting to get toward the solution to the UFO enigma. And so all that other stuff was basically background. It turns out that the holy grail of modern physics is uniting the 4 fundamental forces of nature into a single superforce, which is what they believed existed at the very beginning of the universe. And so if you ever wonder what physicists are doing, this is it. That one slide tells you what virtually every physicist is working on in one way or another. And at the very beginning of the universe, at the time of the Big Bang, 14 billion years ago, the forces of, at the time of the Big Bang, it created 2 other forces. Oh, by the way, I forgot to mention, physicists are particularly interested in the forces of nature, and the reason is because the forces of nature make things happen. So, for example, the electromagnetic force in a lightning bolt, that's what causes things to happen. And so they pay more attention to the forces of nature because that's what makes things work in the universe. So anyway, at the time of the Big Bang, almost immediately after the Big Bang, within a few seconds, 2 new forces were created, gravity and the GUT force, G-U-T, which stands for the Grand Unified Theory. But then the GUT force broke out into the strong nuclear force, circled in red there, and the electroweak force. And then the electroweak force broke out into, as the universe expanded and cooled, it broke out into electromagnetism and the weak nuclear force. And the forces that we see today are, as we saw before, the ones circled in red, strong gravity, weak, and electromagnetism. And they've been working on unifying these 4 fundamental forces, and they've actually had some good success. It was once thought that the electric force and the magnetic force were separate, but James Clerk Maxwell in Scotland in the 1850s united them in Maxwell's laws into what we now know today as electromagnetism. And amazingly, the electroweak force, which is the combination of electromagnetism and the weak nuclear force, it has actually been seen in particle accelerators. They've actually recreated this electroweak force. And they're working on trying to unite the strong nuclear force and the electroweak force into the GUT force, like we saw on the previous page, in the Grand Unified Theories. But the key thing, and this is where we need to pay attention because this is where we're going to solve the UFO enigma, I believe. And The one force that's not included in any of these unification theories is gravity. And gravity is the only force that they have not been able to include in the various unification theories. The question is, why not? Why can't they get gravity in there? And the reason is, if you compare the strength of the various forces, what jumps out at you is how incredibly weak gravity is compared to the other forces of nature. And, you know, when we get up in the morning and have to go to work, I can attest to this. Until I have my first cup of coffee, gravity seems like an unbelievably strong force. So, and I'm sure people can, you know, share with that experience, you know. But anyway, but it's incredibly weak. And in fact, the electromagnetic force is 10 to the 36th power stronger than gravity. That's the number 1, followed by 36 zeros, all the way over to the wall. And I mean, it's just unbelievable. 100 is 10 squared, 1,000 is 10 cubed, 10,000 is 10 to the 4th. Imagine 10 to the 36th power. And electromagnetism is that much stronger than gravity. And in fact, this is such a big problem in physics that it actually has its own name. It's referred to as the hierarchy problem. And I believe that the solution to the hierarchy problem is going to lead us to an understanding of UFO technology. And I want to also mention that the hierarchy problem is also equivalent to, afraid this is a little more physics, but this is not too bad. It's also equivalent to the puzzle of the weak mass versus the Planck mass. And all that means is all the known subatomic particles, the quarks, the leptons, everything like that, are that we see in our universe today are at a much, much lower mass than they should be. In order to make gravity strong, these particles really should be 16 orders of magnitude have a greater mass than they are than what we see. But the problem with that, if they were at that much higher mass, unfortunately the entire universe would disintegrate, which is a bit of a problem. And so, but anyway, I went to to truly understand the magnitude of this problem, I went to an expert to get his opinion, and so, and not only will Homer Simpson's favorite donut shop disappear, but all of our favorite donut shops will disappear along with everything else. So you can see this is serious, you know. And thank you, Homer. And so what we're going to do, so now what we're going to do is we're going to look at the evolution of modern physics to see what new theories are coming up that could help us explain the hierarchy problem. And this is really exciting. You'll see what's going to happen here. The theories in black at the top, the 4 theories up there, are basically known physics that we see, that it's accepted physics that we fully understand. It has been thoroughly tested. Classical mechanics like Newton and Maxwell's laws, general relativity, quantum mechanics, and then the Standard Model is just a synthesis of special relativity and quantum mechanics. However, what you want to pay attention to here on this slide are the new theories that are coming out in blue and green down below there. And these came out in the 70s, 80s, and right up now until 2015. And don't worry about memorizing all this, supersymmetry, supergravity, all that stuff, superstrings. The key thing the takeaway from this slide is a couple of things here. What had happened is physicists were trying to unify the forces of nature, but they were having a lot of problems. And they ran into roadblocks by about the 70s and 80s. So they began looking at different ideas to see if they could figure out how to unify the four fundamental forces of nature. And finally, around the 70s and 80s, they began playing with the idea that there might be extra dimensions. So that's one of the key things you want to remember from this slide. And right now, string theory, and then they came up with theories called string theory, which I'm sure many people have heard of, and membrane theory. And string theory is basically the idea that all the subatomic particles, which were once thought to be little points, infinitesimally tiny little points, they now suspect that they're actually little wiggling strings. And so, but once they made that leap to the idea that they were wiggling strings, that's when they they were forced to introduce the idea of extra dimensions. And so then the other big thing that happened in the last 25, 30 years here is they came up with the idea that we may live on a space-time membrane, and they think it's a membrane floating in a larger dimensional space out there. And so we'll take a look. So modern physics is pointing toward an 11-dimensional universe, but it turns out that 6 of the 11 dimensions are curled up at every point in space-time, but this leaves 5 large dimensions left, and historically we thought there were 4, 3 of space and 1 of time. And now theory also suggests that there are 2 4-dimensional membranes that are floating out there parallel to each other, and they float in a larger 5-dimensional space. And here's an illustration that gives an idea of what it looks like. All those little green strings, those are the strings that represent every single one of the particles that we looked at before, the matter particles and the force particles. But the interesting thing is, string theory suggests that all those little particles are stuck on the space-time membrane we live on. And as I mentioned, it looks like there are 2 space-time membranes floating parallel to each other. And so all these wiggling little strings that represent matter particles and force particles, the 2 open ends are stuck on the membrane, so they cannot leave that membrane. And so the photon that carries light waves that we need to see with, because the photons hit the retina and bounce off the retina at the back of our eye, or absorbed, I should say. But we need photons to see, but those photons cannot get into this extra 5-dimensional space between the 2 membranes that are believed to exist out there. That's why you cannot look out there and see the 5-dimensional bulk. It's actually right next to us right now. We just can't see it because the photons that we need to see with cannot penetrate. They cannot leave our space-time membrane. However, there's one particle that can leave our space-time membrane, and it turns out that that's the graviton, the carrier of gravity. And the only reason it can leave is because it's a closed loop. And so it doesn't have 2 open ends, it's closed, so it can just leave our space-time membrane. And that's exciting, because that looks like it's pointing toward an explanation of the hierarchy problem, the weakness of gravity. And here's where we're honing in on the explanation of how UFOs work. There's a theory that was developed by a Harvard physicist and another physicist from Johns Hopkins University, and it's called warp geometry, and it addresses the hierarchy problem, the weakness of gravity versus the other forces in nature. And it explains why gravity is weaker than the other forces. And what warp geometry says, that just like M theory and string theory, that there are two four-dimensional membranes floating in a larger five-dimensional space-time. One membrane we live on, they refer to as the weak membrane, and all that means is that the energy level of the particles on our membrane are relatively weak. And the second membrane, which is called the gravity membrane, exactly parallel to our weak membrane, they believe that that membrane is on the other side of the five-dimensional bulk. And here is how their theory works. What they believe is that the gravity brain, the other one that's opposite ours or parallel to us, is warped in such a way that it attracts virtually 99.99999% of all the gravitons that carry the gravity force into the bulk and closer to the other membrane. And I can illustrate it here. What they call the gravity probability function is that red line, and the closer you get to the gravity membrane, the greater the number of gravitons over there. And in fact, there are 10 to the 16 times power more gravitons closer to the gravity brain than to the weak brain. And that's it. And I know this it looks so technical and everything like that, but it's actually pretty basic. All that they're saying here is the overwhelming majority of gravitons that carry the gravity force are closer to the other to the other membrane, so they're not on our membrane, which is our universe. And that appears to be why gravity is so weak compared to the other forces of nature in the weak membrane, or sometimes called the TEV membrane, that we live on the left side there. That's it. And that it looks like this Harvard University physicist may have come across an explanation for the hierarchy problem. And he inadvertently, the Harvard physicist also, in my opinion, may have explained UFO technology. Here's why. This is it. It turns out that where general relativity tells us that where gravity is strong and where you have a lot of gravitons as you get closer to the gravity brain in the five-dimensional bulk, they refer to that space-time between the membranes as the bulk, B-U-L-K. But general relativity tells us where gravity is strong, distances shrink. And that, I believe, is the key to how UFOs get to planet Earth. And the exciting thing about this is that in the past, we used to think that to get to other star systems, we would have to either go at the speed of light, which would take us years and decades to get to those stars, or we would have to come up with gigantic amounts of energy to warp space-time ourselves to get to other stars, to shrink it in front of our spaceship. However, if this theory turns out to be correct, Mother Nature may warp space-time for us. And therefore, if we can only figure out how to get into the five-dimensional bulk, we could actually go in far enough where distances between stars shrink and we could get to other stars. And that's what this slide covers here. I believe the UFOs penetrate the bulk to go between stars, and Mother Nature then provides a pathway to the stars. We don't have to do it. And the other important thing out of this is we do not need huge amounts of energy to warp space-time. And that was a major obstacle to previous attempts to figure out how we could travel to other stars. And this is another illustration. It shows how distance shrinks as you go deeper into the five-dimensional bulk. And then this slide is very important, so I know it's a little technical, but all it's showing is the collision of two protons at like the Large Hadron Collider Particle Accelerator in Geneva, Switzerland. And if these extra dimensions exist, they expect to create a new type of particle that has never been seen before. And it's called a KK particle, a Kaluza-Klein particle. And it's going to be a manifestation of the extra dimensions. But the KK particle, its natural home is in the five-dimensional bulk. It's going to want to go into the five-dimensional bulk. Right after we create it at the Large Hadron Collider, that little baby, that little KK particle is going to say, I want to go home, you know, and it's going to try to get to the it's going to go into the 5D bulk. And that's how I believe UFOs are getting into the bulk. They create these five-dimensional KK gravitons, and they pull themselves off our weak brain into the bulk. And the more KK gravitons they create, the further into the bulk they can go. And here's something really interesting. Many people may have heard of Sir Francis Chichester. He's a world-famous pilot who was very prominent back in the 1930s and 40s, and he was a pioneer in early flight years. And anyway, over the Tasman Sea, between Australia and New Zealand, or Tasmania, I guess, and in 1931, he was flying a Gypsy Moth aircraft and a biplane, and he spotted a typical UFO, typical disc-shaped UFO, maybe half a mile from his aircraft. And as he watched it, he noticed it was coming toward him, but as it got closer to him, it became smaller in size, which is exactly the opposite of what he expected. And then when it became very close to him, at one point he could see right through it, and then it totally vanished. And the interesting thing is, moments later, it reappeared about another mile away, and it suddenly seemed to it come back into existence again, but he did not see it move between the 2 points. It just became, it faded out, and then it popped in at another location. And I believe that's an early example of a UFO pulling itself off our membrane into the bulk and then just moving a short distance. And that's what Sir Francis Chichester observed. And he's a very credible witness, so I thought that was quite interesting. And here's an example of what it would be like if we can get into the bulk and use that strong gravity, which shrinks distance between the stars. I'll show you an example of the impact it would have on space travel. This is pretty neat. The nearest star to planet Earth is Alpha Centauri, which is 4.3 light years. That's about 25 trillion miles. If we tried to get there by any of the methods I mentioned at the very beginning of the show, it would take decades and decades to get there, actually probably over a century. But if we only went into the bulk, the five-dimensional bulk, to just one where the force of gravity increases only to 1/10,000th of its maximum strength in the bulk, the distance to Alpha Centauri shrinks from 25 trillion miles, 4.3 light years, to 25 miles. Isn't that incredible? And anyway, I think that's what they're doing. But anyway, so as surprising as it may seem, so anyway, 25 miles, you could literally drive to Alpha Centauri in your car, depending in half an hour, depending on the speed limit and the bulk. The cosmic police. And so as surprising as it sounds, it may be possible to get to other stars very, very quickly. And I know it seems, very amazing, but it looks like it's likely. And I don't know if you can see that slide. That's Bart being sucked up into the UFO. and Homer is not quite aware of it. And he says Bart can go to Alpha Centauri in just 30 minutes. Yeah, sure. and so on the two big questions on UFO technology, how did they get here? And how are they able to perform inertia-defying acrobatics in Earth's atmosphere? It looks like the first one can be solved if the warp geometry theory is correct, and the extra dimensions exist, and the bulk is warped like they say it is. If that's true, then we may be on the threshold of understanding UFO technology. And by the way, that's one reason to pay close attention to what's going on at the Large Hadron Collider in Geneva, Switzerland. If they discover extra dimensions in the next couple of years, this could be very exciting and very pertinent to the question of the UFO phenomenon. And now, on the second question, we'll look at that next, how these craft are able to apparently overcome inertial forces in Earth's atmosphere. This is a lot easier. And those KK gravitons that I mentioned before create micro black holes. We expect to do that at the Large Hadron Collider. And these black holes will decay into something called Hawking radiation, which will consist of electromagnetic particles, electromagnetic energy, as well as solid particles like high energy electrons called beta particles. And that will produce something we call, that is called Hawking radiation, named after Stephen Hawking. And Mark D'Antonio, who spoke just before me, he and Doug Trumbull and MUFON are working on detectors that hopefully will be able to detect Hawking radiation. And if we do, that would be extraordinarily interesting. Oh, and by the way, I should mention, nobody has ever seen Hawking radiation, so that'd be a real feather in the cap for the UFO community if we were the first. But physicists strongly believe it's real. Anyway, here's the key to UFOs, how they levitate and stuff. Four-dimensional gravitons are absorbed by micro black holes. And so what I believe is going on is the graviton exchange between the Earth and the UFO, which is how the Earth measures the weight of an object, is reduced. And so this is not anti-gravity. It's actually the reduction of the effective mass of the UFO. So if it's a 30-ton UFO, it can be reduced to the mass of a Frisbee, a Frisbee weighing 5 ounces. And the interesting thing about that is, if you've ever taken a Frisbee and tried to throw it across the yard, one of the things you have to do to stabilize it is to spin it. And everybody who's followed the UFO phenomenon is aware that these circular disc UFOs are typically seen spinning. So that's probably an indication that they're reducing the mass of these things. They're so lightweight, as far as the Earth is concerned, they have to spin them to stabilize them. And and this is an illustration. I think what the UFOs are doing is they're creating these KK gravitons, which in turn create micro black holes, which in turn absorb gravitons, which in turn effectively reduce the mass of the UFO. And this is a more detailed explanation of the absorption and emission of a micro black hole. We don't really have to go into that. And so how do UFOs accelerate at their blinding speeds? Here's how they do it. The equivalence principle of general relativity says inertial mass equals gravitational mass. And so if a UFO can reduce its gravitational mass, its effective gravitational mass, it reduces its inertial mass. And inertia, as I mentioned way back at the beginning, is the resistance to acceleration. Think of a cannonball fired out of a cannon. It takes enormous energy On the other hand, if you fire just a tiny little .22 bullet, it accelerates at blinding speeds. And the difference is simple. The bullet has very little mass, so it's easy to accelerate it fast. But a cannonball, it has such great mass. You can actually, if you've ever seen a cannonball fired, you can actually see its trajectory. You can see the cannonball flying through the air. That's what they're doing. And I think that's how they're able to make these sudden accelerations. So what about the Large Hadron Collider particle accelerator in Geneva, Switzerland? How could that possibly be related to UFO configurations? It turns out the Large Hadron Collider is expected to produce KK gravitons and micro-black holes, and which we need if the UFOs are using micro-black holes to absorb four-dimensional gravitons. And as we found out, UFO configurations are typically disks, cylinders, or spheres, and even the triangle UFOs have bright circles in each corner. So why do UFOs have this circular shape? Because UFOs are particle accelerators. That's what they are. And that's part of the reason they don't make much noise, because they're not operating a reciprocal engine or a jet engine or anything like that. And one of the interesting things is that there's circumstantial evidence that supports these possibilities. One is a UFO observed in Sonora, California, and another one is a crisis in modern physics. In Sonora, California in 1976, a substance called tritium was found in angel's hair. People who follow the UFO phenomenon are familiar with angel hair. Tritium is an isotope of hydrogen, and it's rare in nature, but it is found in particle accelerators. And that's what they found being emitted from a UFO. Angel hair would typically settle on the branches of trees and stuff. And then the second thing is a crisis in physics. And the crisis in physics deals with something called, a theory called supersymmetry, which was supposed to solve the hierarchy problem, the weakness of gravity versus the other forces. And just to give you an idea how important supersymmetry is, huge, thousands and thousands of physicists have spent 30, 40 years working on supersymmetry. And that was the alternative theory, that was the basic theory they were going to use to solve the hierarchy problem. However, in the recent runs of the Large Hadron Collider, they did not find any of the predicted supersymmetric particles. So that's exciting because it means the alternative theory, warped geometry, that we need to solve the UFO enigma is now more likely. And the final slide, just a few left here. We'll look at the known effects of UFOs and expected effects. Can we prove, and where do we go from here? And here's 4 typical effects of UFOs in close encounter. There's evidence of strong magnetic fields near UFOs because pilots often report their compasses spinning wildly. There's indications of strong, attractive gravity field, as I mentioned at the beginning. There are certain types of radiation, especially gamma rays, X-rays, high-energy radiation, and there are many reports, as we saw, of UFOs becoming partially or totally transparent. And now here are the expected effects if UFOs are using the technology we just talked about. Turns out that micro-black holes, as we saw way back at the beginning, create strong magnetic fields. And that's exactly what pilots report when they're near UFOs. Their compasses are spinning wildly. KK gravitons that are needed to create the micro-black holes create a strong, short-range attractive gravity field, which must be what's causing objects, as the UFO gets close to the planet Earth, it causes things to be lifted up underneath. The third thing, micro-black holes will decay into Hawking radiation, which, as I mentioned, MUFON, Mark D'Antonio, and Doug Trumbull and others are hoping to build detectors for to detect. It turns out Hawking radiation decays rapidly. Micro-black holes decay into Hawking radiation into gamma rays and X-rays. And so that's exciting too, because that's exactly what we're seeing. And then finally, if a UFO is going into the weak brain, we would absolutely see it become partially transparent and then disappear. Can we prove? Well, yes, the Large Hadron Collider will give evidence confirming or disproving M theory and warp geometry. And then on the second item, we need more data, which I'm hoping that Mark and MUFON and Doug Trumbull will be able to give us. And where do we go from here? Basically, we're looking for the unique spectrum of Hawking radiation. And as I mentioned, it'll decay into various forms of radiation. And if we do detect Hawking radiation, it would virtually confirm that these UFOs are using M theory, warp geometry, KK gravitons, and micro black holes. And I admit that we cannot predict the appearance of UFOs, but they are often seen multiple times in the same geographic area. So we might be able to set up equipment in an area where there's a lot of UFOs. And here's just a few quick pictures of UFOs. You notice these glowing UFOs here. And here's one seen over Belgium. Here's another one taken by a fighter pilot. And here's another one taken by the US Air Force. It appears to be a probe. It's a small one following the aircraft here. Here's another one taken from the gun camera of a French fighter jet. And here's a cutaway of the Large Hadron Collider in Geneva, Switzerland. Gigantic device, something like 27 miles in diameter. And they have 4 detectors that are used to detect the collisions of subatomic particles that are going near the speed of light. And here's a look inside the tunnel of the Large Hadron Collider. This is gigantic. And this gives you an idea. This is one of the detectors. If you look in the lower center of the photo, you'll see one of the workers. You can see how tiny he looks there compared to the size of the detector. That's pretty amazing, you know. And I just want to mention something very important here. When they first brought up the Large Hadron Collider, within a few, almost immediately, they had a major problem. The whole thing crashed. And so they spent quite a bit of time trying to figure out who was responsible for crashing this $10 billion piece of equipment. So the security police for the Large Hadron Collider spent a long time, but they finally located the culprits responsible for crashing the Large Hadron Collider. Actually, what happened is there are many different groups working on the collider, and they found bubble gum jammed into some of the sensitive electronic, if you can believe it. But they finally caught the culprits. And that little guy in the middle, the bottom middle there with 2 thumbs up and the orange shirt, they think he's the ringleader. and that concludes my talk. Thank you, John. Okay, yeah. Okay.